Guys, shh. So let's talk 6.3. So I'm on page 9 of your packet. All right, so shh. Little bit of a review from yesterday, plus a slight bit of new stuff. So, definition of a circle, we already talked about this. It's just a collection of points on a plane with a fixed distance formed from a fixed point, known as its center. So, fixed distance is its radius. The fixed point is its center. Now, some different type of segments. You got a radius, which is a line segment drawn from the center of the circle to any point on the circle. A chord, which is a line segment that has both of its endpoints on the circle. And a diameter, which is a chord that passes through the center of the circle. All right. So let's do some questions involving this. So we're going to list 3 different line segments that represent the radii of this circle. So remember, radii is just the plural for radius. So someone raise their hand and tell me one radius. Tobias. So BA is 1. Someone else tell me another one. DA. And then AC. So this is a radius. This little piece is a radius. And this little piece is a radius. Now, shh. What segment do you think represents the diameter of the circle? Someone raise their hand and tell me. Zimara.
Because if I say it, I'm going to get it wrong.
Say it.
A?
That's the center.
Told you.
All right, someone who has not talked yet. So you two, you've talked. Which segment's the diameter? Leighton. Good. So, shh. DC, guys, please stop talking. So, DC is your diameter. Now, who remembers what the length of the diameter represents versus the length of a radius? So, how they connect?
Diameter is double the radius.
Right. So, remember, a diameter is equal to twice the radius. Because if you think about it, since a radius is drawn from the center to the edge of the circle and a diameter has to go through the center, that means it has to be made up of 2 radii. All right, because one side is a radius, the other side of the center is a radius. Now, we're now going to list all of the chords. So remember, a chord is both endpoints of the segment are on the circle. So someone raise their hand and tell me one chord. Someone who has not talked yet. Paula. DB is a chord. Someone else, raise your hand. Not DA, not quite. Jason. Nope. Ziamara.
Wait, is it AC? DC?
DC, good. So remember, chords mean that both endpoints have to be on the circle. The reason that the radii are not chords is because the center is technically not on the circle, it's in the circle. All right, so this would be a chord, and the diameter itself would be a chord because both endpoints are on the circle. They physically got to be on that circle. Now, they then want us to explain why triangle DAB, so this triangle right here, why they think it's isosceles. So first off, what does it mean for a triangle to be an isosceles triangle? Nope. That's equilateral.
2 sides are equal.
2 sides are equal. 2 angles are equal, 2 sides are equal. So why are they saying that there are 2 of these sides of this triangle are equal? Look
No,
what
there's two radius.
there's two radii. So in other words, because a radius always has to be congruent to every radius in that same circle, that is an isosceles triangle because we have two congruent sides. So it's because two of the sides are made from a radius and radii in a circle are always congruent. That's why. So no matter what radius I draw in this circle, it will always be congruent to any other radius in that circle. Now, in circle M, point A is located on the circle such that AM is equal to 2x plus 7. If the diameter is 74 units long, what is the value of x? So if I go back and label this, or no, different circle. So I'm going to draw a circle, and it's labeled circle M. So that means the center is what? M. So remember, you label a circle based off of its center point. Now, it says that point A is located on the circle such that the segment AM is equal to 2x plus 7. They then say that the diameter, so let's say the diameter was right here, and we don't know what the letters of it is, we just know it's the diameter, is equal to 74 units. So this diameter is 74 units long. And they want us to know what the value of x is. So let's think about this carefully. What would AM be considered? What type of segment? A radius. So if this is considered a radius, and we know what the diameter is, how do you think I'm going to set up my equation to solve for x?
2 times 2x plus 7 is equal to 7.
Right. You do 2 times 2x plus 7, because remember the diameter is twice the radius, and it's equal to 74. Yes. Yeah, you could divide 74 by 2 and set that equal to 2x plus 7. So that would have worked also. So first off, I would divide by 2. So you could distribute if you want. I'm just going to divide so I have smaller numbers. So this is 2x plus 7 is equal to 37. So I'm going to subtract the 7 to both sides. I get 2x is equal to 30. So x is equal to what if I divide by 2? 15. So that's how you have to think about it. If they say that it's on the circle and it's going from the center to the edge of the circle, it's a radius. And if they give you the diameter, we can assume that that expression is twice twice that expression is equal to the diameter. All right. Any questions on this one? Now, the rest of this talks about what we talked about yesterday with the arcs and the central angles. So, let's review. So remember, what's the difference between naming a minor arc and a major arc? Someone has not talked yet. So what's the difference between when you name a minor arc versus a major arc? Say it again. Minor is less than 180, and a major is greater than 180. So what's the difference in naming them? How many letters do I use to name a minor?
There's 2 points in minor, there's 3 points in major.
Good. So you use 2 points to name a minor arc, 3 points to name a major arc. So, first off, they want us to name the major and minor arc that go through the endpoints A, B. So A and B are their endpoints. So these should be the points that our arc ends with. So how would I name the minor arc? Which one would be the minor arc, first off? So where A and B are the endpoints. So that means they start at A, end at B. Just AB. So we would name it as arc AB. So this arc right here would be my minor arc. What about the major arc? So now we're looking at the other side of A to B, and you need 3 points. So what's the other way you can name them? ACB. So you could do either ACB or you can do ADB. Because remember what I said, it doesn't matter what the middle point is as long as it's between A and B. So both of those represent the same arc. All right. What about for AC? So now we're saying that we're looking at points between A and C. So A and C are now my 2 endpoints. So I start at A, I end at C. How would I name the minor arc? AC. So that's this little arc right here. How would I name a major arc? There's only one way to name the major arc. CBA or ACB or ABC, either way. So ABC.
Why not ABC?
So we can't do ADC because that's still the minor arc. I'm looking at the major arc, so the one that's greater than 1 so the one over here. All right. Any questions on that? All right. And then lastly, central angles. So remember, a central angle is in any angle in a circle that the center of the circle is its vertex. So that means the point that makes the 2 angles, or the vertex, is at the center of the circle. Now, what's always true about central angles in terms of their measure? They're congruent to the intercepted arc. And remember, the intercepted arc, it's like the ice cream on the cone. All right, if the angle's the cone, the intercepted arc is the ice cream on top of the cone. All right. So, circle B below has various points located on it. And it wants to know which angle listed is a central angle. So, let's just go through all of them. So, DAE. So, DAE. Is that one a central angle? So, is its vertex at the center? No, its vertex is on the circle. We'll learn later that that's known as an inscribed angle, but for right now, it's not central. What about CBA? Is that a central? Yeah, it goes through the center. I'm still going to check the other ones though. What about CEB?
No.
No, its vertex is on the circle. Then what about ACB? No, vertex is on the circle. So the only one that works is CBA. Now, another way you could have known is, since the center is B, what has to be true when we name a central angle? Right. The letter of the center has to be in the middle. So that's the only one where B is in the middle, so that had to be our central angle. All right, last one. So, if ADB is defined as 112, what is the measure of arc AB? So this arc right here. 112. That's the ice cream on top of the cone. So this is 112 degrees. What about ACB? So this side. It's not 180. Right. So I would do 360 minus 112, which would equal what? 248. All right. Any questions on that? Any questions on anything with 6.3? All right. So what we're going to do right now is we're going to do a quick quizzes. All right. It's going to be together as a class, but it's at your own pace. All right. So it's not assigned to you. You got to put the code in.